What is an amniote? Amniota is defined as a group of limbed vertebrates, which includes all the living reptiles, class Reptilia, mammals, class Mammalia, birds, class Aves, and their extinct ancestors and relatives. Amniotes examples. The amniotes are the evolutionary branch, called clade, of the tetrapods, which are superclass Tetrapoda, where the embryo develops within a set of protective extraembryonic membranes, the chorion, amnion, and allantois. A few amniotes examples are reptiles, turtles, mammals, snakes, lizards and more. About amniota. Let us know what is an amniote in brief. The chorion, amnion, and allantois of the amniotes likely evolved from the embryonic tissue layer by encasing a large yolk mass. In living reptiles, a cell sheet grows outward from the embryo. This specific growth, in combination with the torsion of the embryo itself and growth, causes this tissue's external layer sheet to fold over the embryo from head to tail. When all these folds meet above the embryo, they fuse. The tissue sheet that becomes a tough, fluid-filled sac known as the amniotic membrane is made up of an inner amnion layer and outer chorion layer. The amniotic membrane function is largely protective, but the allantois serves as a collection area for the waste materials and as a site of gas exchange. Allantois forms as an outpocketing of the hindgut of the embryo and grow outward into the space between the chorion and amnion. An amniote egg is represented as follows. The arrangement of extraembryonic membranes is an evolutionary adaptation, which permits egg deposition in terrestrial environments. As a result of this particular change, tetrapods could become completely terrestrial. In birds and reptiles, the chorion, amnion, and allantois are further protected by a leathery or hard calcareous shell. In most mammals, and a few live-bearing lizards, a portion of the amniotic membrane and allantois forms the placenta, which is a vascular organ that facilitates the exchange of both the nutrients and waste products between the growing fetus and its mother. Description. Zoologists characterize amniotes in part by embryonic development, which includes the formation of many extensive membranes, the chorion, amnion, and allantois. Amniotes typically develop directly into a terrestrial form with limbs and a thick stratified epithelium, rather than first entering the feeding larval tadpole stage followed by the metamorphosis, as amphibians do. In amniotes, the transition from the two-layered periderm to a cornified epithelium is triggered by the thyroid hormone in the time of embryonic development rather than by the metamorphosis process. The unique embryonic features of the amniotes can reflect specializations for the eggs to survive drier environments, or the increase in yolk content of eggs and size can have permitted, and coevolved with, direct development of the embryo to the large size. Adaptation for terrestrial living. Amniotes features evolved for survival on the land include a sturdy but hard eggshell or porous leathery and an allantois, which facilitates respiration while providing a reservoir for the disposal of wastes. Their large intestines and kidneys are also well suited to water retention. Most mammals do not lay eggs, but the corresponding structures develop inside the placenta. The true amniotes' ancestors, such as Cassiniariidae, which lived up to 340 million years ago, evolved from the amphibian reptiliomorphs and resemble small lizards. At the late Devonian mass extinction, or 360 million years ago, all the known tetrapods were importantly fish-like and aquatic. Because the reptiliomorphs were established already 20 million years later when all their fish-like relatives were extinct, it appears as they separated from other tetrapods somewhere during the Romer's Gap. When the adult tetrapods became completely terrestrial, a few forms would later become secondarily aquatic. The modest-sized ancestors of the amniotes have laid their eggs in moist places, such as depressions under the fallen logs or any other suitable places in the forests and carboniferous swamps, and dry conditions probably which do not account for the emergence of soft shell. Indeed, several modern-day amniotes need moisture to keep their eggs from desiccating. Although a few modern amphibians lay eggs on the lands, all the amphibians lack advanced traits like an amnion. The amniotic egg has formed through a series of evolutionary steps. After the internal fertilization and laying eggs habit in terrestrial environments became a reproduction strategy amongst the amniote ancestors, the next primary breakthrough appears to have involved the gradual replacement of gelatinous coating by covering the amphibian egg with a fibrous shell membrane. This has allowed the egg to increase both the rate of gas exchange and its size, permitting a larger, metabolically active embryo to reach full development before hatching. Further developments, like extraembryonic membranes, chorion, amnion, and allantois, and a calcified shell, were not important and probably evolved later. It has been suggested that the shelled terrestrial eggs with no extraembryonic membranes could still not have been more than up to 1 centimeter (0.4 inch) in diameter due to the diffusion problems, like the inability to get rid of carbon dioxide if the egg was larger. The combination of the absence of a larval stage and small eggs, where post-hatching growth takes place in an amniotic tetrapods before turning into juveniles, would limit the adult size. This is supported by the fact that extant squamate species, which lay eggs less than 1 centimeter in diameter, have adults whose snout vent length is below 10 centimeters. The only way for eggs to increase their size would be to develop new internal structures which are specialized for respiration and for waste products. As a result, the juvenile's ability to grow before reaching adulthood would be harmed. The egg membranes. Amphibian eggs and fish have only a single inner membrane, which is the embryonic membrane. The amniote egg evolution needs an increased exchange of gases and wastes between the atmosphere and embryo. Structures to permit these traits allowed for further adaptation, which increased the feasible size of amniote eggs and enabled the breeding in progressively drier habitats. The increased egg size permitted an increase in the size of offspring and consequently of the adults. However, further growth for the latter was limited by their terrestrial food chain position, which was restricted to level 3 and below to it, with only invertebrates occupying level 2. Eventually, amniotes would experience adaptive radiation when a few species evolved the ability to digest the plants and new ecological niches opened up by permitting the larger body size for herbivores, predators, and omnivores. Amniote traits. While the early amniotes and anamniotes resembled their amphibian ancestors in several respects, the key difference was the lack of an otic notch at the skull roof's back margin. And, in their ancestors, this particular notch held a spiracle, which is an unnecessary structure in an animal without an aquatic larval stage. There are the 3 primary lines of amniotes that can be distinguished by the structure of the skull and, in specific, the number of temporal fenestrae, openings, behind each eye. In anapsids, which is the ancestral condition, there are none. In synapsids, mammals including their extinct relatives, there is 1, and most diapsids, including crocodilians, birds, tuataras, and squamates, there are 2. Turtles were traditionally classified as anapsids due to the lack of fenestrae, but molecular testing firmly places them in the diapsid line of descent. They hence secondarily lost their fenestrae. Postcranial remains of amniotes and anamniotes may be identified from their respective labyrinthodont ancestors by their having at least 2 pairs of sacral ribs, which is a sternum in the pectoral girdle. A few amniotes have lost it, and an astragalus ankle bone. Traditional classification. Amniotes are divided into the taxonomic groups as listed below. Birds, aves, there are up to 10,000 species of birds alive now. Members of this group are given as birds of prey, game birds, perching birds, hummingbirds, kingfishers, loons, button quail, pigeons, owls, albatrosses, parrots, penguins, woodpeckers, waterfowl, and several others. Birds have several adaptations for flight, such as hollow bones, lightweight wings and feathers. Mammals, Mammalia, there are up to 5,400 species of mammals alive now. Members of this group are given as bats, primates, carnivores, aardvarks, seals, and sea lions, insectivores, cetaceans, elephants, hyraxes, rodents, hoofed mammals, and several other groups. Mammals have many unique adaptations, including hair and mammary glands. Reptiles, Reptilia, there are up to 7,900 species of reptiles alive now. Members of this group are given as snakes, crocodiles, lizards, alligators, tortoises, caimans, turtles, worm lizards, and tuataras. Reptiles have scales, which cover their skin, and they are cold-blooded animals. The eggs of amniotes. The eggs of several amniotes, such as most reptiles and birds, are enclosed in a hard and mineralized shell. This shell is flexible in many lizards. The shell provides physical protection for the embryo, including its resources, and limits water loss. In amniotes that produce shell-less eggs, such as some reptiles and all mammals, the embryo develops within the reproductive tract of females. Non-amniotic egg. The amniotic egg contains numerous distinct structures. At the egg's innermost part, the embryo is suspended by the amniotic fluid that is surrounded by a membrane known as the amnion. The allantois deals with the waste and gas exchange and also, together with the nutritious egg yolk, connects to and partially surrounds the embryo. The chorion surrounds all these structures and separates from the albumin, the egg whites. All these components are enclosed in the outer shell. The shell is calcified in most snakes, turtles, lizards, crocodiles, and birds. However, the animals who give birth to live young enclose their young in the non-calcified flexible shells, which rupture near the time of birth. Did you know? Vertebrates that develop without extraembryonic membranes are called amniotes. They do not belong to the formal classification group due to they are associated with the absence of a characteristic. Among the tetrapods, amniotes include extinct and extant amphibians and the two groups of extinct reptile-like animals, the Brachiosaurus and Anthracosaurs. Conclusion. Amniotes are the clade of tetrapod vertebrates comprising birds, reptiles, and mammals. These are characterized by an egg equipped with an amnion, an adaptation to lay eggs on land or retain the fertilized egg within its mother. We can see amniotes at various places irrespective of the climatic conditions and locations that we are living at.